All right, so today we're going to focus on graphing linear inequalities. So this can also be broken down in a step-by-step process. Step one is, if needed, rearrange the inequality so y is on the left side all by itself. This will create the inequality to be in slope-intercept form. So in other words, you're solving for y. Just like we have done a million times with equal signs, we're going to do the same thing. We're just going to deal with the inequality. Step two says, graph the same way you would graph a line with one exception. If you have just the greater than or less than without a bar underneath it, you're going to graph those as dotted lines. So if there is a bar underneath it, you'll graph those as solid. But if there is not a bar underneath it, like it says here in the text, you are going to graph it as a dotted line, and we'll have some examples of these. Step three, you will need to shade one side of the graph. Use the y-axis as your determining factor to help you shade. Read the inequality to determine where you will shade. If it is greater than, or in that same manner, greater than or equal to, shade where the y values are constantly increasing. If it is less than, or less than and equal to, so if the bar is underneath it, shade where the y values are constantly decreasing. All right, so here's an example. We're going to graph the equation y is less than 3x plus 8. So I've already set up the graph just so we can proceed in this process. So I'm going to graph it exactly the same way I have been. So I'm going to look and I'm going to say, all right, this is the same thing as saying as y is less than mx plus b, where m, remember, is my slope, and b is my y-intercept, which means where it crosses the y-axis. So I'm going to go up to 8 on my y-axis. And remember, this is my y, and that's my x. So I'm going to count up to 8. So I've got 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to put a dot there. 1, 2, 3, 4, 5, 6, 7, 8. Yes. Okay. So I have plotted my slope-intercept. Now I'm going to move my slope, which in this case my slope is up 3 over 1. Okay, up 3 over 1. Or I could also go in that sense down 3 to the left 1. Again, going in that order, down 3 to the left 1. Okay, so I've got a bunch of dots now. Now remember from that first screen, it said if I have simply greater than or less than without a bar, I am graphing it as a dotted line. Okay, so I just need to remember that. So what I would end up doing, instead of forming a solid line, and it's hard here on the computer, I would do exactly that. I would have a dotted, or you can do dashes if that's easier for you than dotted. You could use dashes, but dashes are dotted line, representing that you cannot count exactly the line. Okay? So we're not done with this problem. We need to talk about our shading. We didn't discuss that earlier because we had to actually graph the line. So if we were shading, we're going to look right here at my equation. It says y is less than. Y is less than. So I'm going to look at this line that I just did a great job drawing here, and I'm going to ask myself, on this y-axis, only on the y-axis, are my y values getting bigger or getting smaller up here? Okay. Well, I know if I keep going up, they're increasing. My y values are getting bigger. Well, over here it says I need y is less than. So I need to go where y is going to get smaller. So y is going to get smaller on here, on this line. Y is constantly getting smaller. Now I could go on to infinity. So thus, I'm going to shade on this side of the line. And yeah, your shading could be just like that. You can shade more solid, but that's a perfect job for shading. All right, so here's another example. We're going to graph the inequality y is less than 2x minus 3. Okay, so again, remembering from before, was on screen 1, I mentioned it on the last example. If you have greater than or less than without the bar, we are going to have a dotted line for our graph. Well, here's an example. We do not have that bar underneath it, or that line, so this is going to be a dotted line when we graph it. So again, first things first, I know that my slope is equal to 2 over 1, and I know that my y-intercept, or my b value, is equal to negative 3. So I'm going to go on my y-axis, and go to negative 3. So I'm going to go down 3, and I'm going to plot a point. Then I'm going to move my slope from that point. My slope is 2 over 1, so I'm going to go up 2 to the right 1. Up 2 to the right 1. Up 2 to the right 1. And you know I could keep going and keep going and keep going. Well, again, going back up to this knowledge right here, this is the difference in the inequality. If it is this, in this case it is, I need to have a dotted line, a dotted or a dashed line. So the point is you're not forming a solid line, okay? So there you go. There is my line. So the thing I need to add to this is now I need to talk about my shading. My shading is where I need to add. So back up here, it says y is less than. So I want to look at this right here. And I want to ask myself, looking at this y-axis, which side of this line, so this side or this side, are my y numbers decreasing because of that less than? Am I decreasing y on this side? No, I'm going up, right? So I am decreasing on this side. So if I would shade on this side of the line. All right, another example. So this says y is greater than or equal to 4x minus 2. So my first thing is I'm going to write down what my slope is, and I'm going to write down what my y-intercept is. So my slope is 4 over 1. My y-intercept is negative 2. So now I'm going to plot that point. But as we're discussing this, notice this time I have greater than or equal to. So that means I'm going to be doing a solid line. Because of that bar right there, I'm going to be doing a solid line when I graph this. So this graph, until I talk about shading, is going to look exactly like y equals 4x minus 2. So we go to our negative 2. Remember, this is our y-axis. This is our x. So we're going to go to negative 2. And now we got to go up 4. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. Okay, that may be all I do. And this time I am forming a solid line. Now, I have to take into account, though, that this is not an equal sign. This is a greater than or equal to. So I have to shade on one of the two sides of this line. So again, here's my line. So I need to ask myself, on this section of the y or on this section of the y, which section is y getting bigger? Okay? So I think we can go. We know that y is increasing up here. The higher up we go, the more it is increasing. It would be decreasing down here. So since it is increasing up here, I'm going to shade on this top portion this time. All right? And that's it. That would be the end to that problem. All right, now notice something about this one. This one says graph 2x plus y is less than or equal to 5. Okay, so this one is a little different because this one is not already set up in the form we need it for. So remember, we want it to be set up in this form, of course, with the inequality taken into account. It's currently not. So, but the joy is I've got this one y right here. That's a 1 for the coefficient for that y. So this is a one-step problem. So I'm going to do my subtraction of minus 2x on both sides. So when I do that, I say subtract 2x, and I'm left with y is less than or equal to negative 2x plus 5. So I've done it. I'm good. And now, again, I'm going to write down my slope is a negative 2 over 1, and my y-intercept is a 5. So again, I'm going to go graph just like I would graph a line. So I go up to 5, 1, 2, 3, 4, 5 on my y-axis, because remember, this is my y, that's my x. And then I need to go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. And again, I can go on forever if I need to. Remember right here, and really right here too, but right here, there is that bar underneath it. So that means I'm going to have a solid line. So when I do so, I draw this line. Okay. However, I'm not done. I'm not done because this is an inequality, not an equal sign. So I am reading this, y is less than or equal to negative 2x plus 5. So I need to look on my y-axis, here or here, and ask myself, where is y getting less than or decreasing? So I know that y is going to continue to get smaller and smaller in this sense. Like we're getting more negative, so it's a smaller number. So thus, I will shade on this side. All right, and one last example on this one. So this says graph 3x minus y is greater than or equal to negative 1. So again, like step 1 says, I've got to solve this for y first. Now, we're going to have to pay attention because you can do this one or two ways. Notice I said in the goal, I want that y to be on the left side. So let's go with that philosophy. Let's make sure we follow through with that. So to do so, I'm going to subtract 3x from both sides. Right now, my problem is a negative y is greater than or equal to negative 3x minus 1. I don't want it to be a negative y. I need it to be a positive y. You guys are awesome at this. So you know my next step is going to be to divide everything by negative 1. Now, remember the rule with inequalities. If I multiply or divide by a negative, I must change my inequality sign. So for my new actual problem that I'm going to be dealing with, it changes to positive y is less than or equal to 3x plus 1. Okay? So make sure if you are going to divide by a negative, you have to deal with that inequality changing. All right? So now again, I've got my slope is equal to 3 over 1, and my y-intercept is equal to a 1. So I'm going to go over here. I've got my y-axis. I've got my x-axis. So I'm going to go to where the y-intercept is 1. And I'm reminding myself of this. So I know I'm dealing with that it's going to be a solid line. So I don't have to worry about, don't stress about that. So I'm going to go up 3, 1, 2, 3, and over 1. 1, 2, 3, and over 1. Okay, so there's my line. And I'm going to draw my line. It's solid because of the bar underneath it. But again, I'm not done because I'm dealing with the inequality. So I have this inequality. So now I'm going to look at this equation right here because this is in pretty form. So this says y is less than or equal to 3x plus 1. So I'm going to ask myself on this y-axis, where are my y's decreasing? Where are they getting smaller? Where are they decreasing? Well, here, they're getting smaller on this side. So thus, I'm going to shade on this side of the line.